Hi everyone, and I hope you have had a great holiday. I'm Christophe Paget, and welcome to your last Espace News weekly episode of the year 2023. As we are ending a rich year full of flight testing, innovation, deep space activities, and a record satellite launch, this week we shall take a little pause and look at our solar system, starting with a refresher course on Saturn. We shall discuss the JAXA mission to our moon, the latest spacewalk from the Chinese space station. We will look at stunning footage of Mars from dawn to dusk, review what is going on at Starbase in Boca Chica, and we shall glide over the launches of the week and conclude with other stunning pictures of Mars. Let us start this week with a compilation from NASA and ESA satellites over the last decades about how beautiful our solar system is, with a look today at Saturn. Saturn rotates around the Sun like Earth does, situated about 9.5 astronomical units from the Sun, or if you like 1.4 billion kilometers, compared to Earth being 1 astronomical unit from the Sun, that's the definition of it, or 150 million kilometers. As a result, Saturn is so far away from sun heat that it is covered with ice, with an average surface temperature at minus 178 Celsius degree or minus 288 degree Fahrenheit. Saturn is about 9.5 times larger than Earth, or 95 times heavier than Earth. A day in Saturn lasts only 10 hours 34 minutes, whilst a full rotation around the Sun, or a Saturnian year, is equivalent to 29.4 Earth years, or 10,756 Earth days. Saturn's atmosphere is approximately 75% hydrogen and 25% helium, with traces of other substances like methane and water ice. Saturn's gravity is 10.4 meters per second square, or about 7% higher than that of Earth, meaning that a human would feel slightly heavier on Saturn than on Earth. His rings looks like a donut. How come it is such a flat ring? Well, the debris in the rings orbit Saturn in a flat plane due to the planet's gravitational pull. Being larger and rotating faster than Earth, Saturn creates more gravitational forces and therefore attracts more debris. Saturn has 146 moons in his orbit today. The scientific community keeps finding moons on Saturn and therefore stopped naming them after the 66th moon in 2004. The moons range in sizes from larger than the planet Mercury, that's the giant moon Titan, discovered in 1655 by Christian Huygens, to a small or as small as a sport arena. Now, the latest found moons were recorded in 2020, called excitingly S2020 S1 through S2020 S10. I don't know why they stopped giving a name to the new moons, but it is a real shame. Japan's space probe called Smart Lander for Investigating Moon, or SLIM for short, entered the moon's orbit on Monday in a major step towards the country's first successful lunar landing, expected on January the 20th, 2024. Now, what you see on your screens are his first moon images. The lander was nicknamed the Moon Sniper because it is designed to land within 100 meters or 328 feet of a specific target on the lunar surface, compared to previous probes that landed a few or over 10 kilometers away from the intended targets. SLIM was originally launched by JAXA Mitsubishi H2A rocket back in September 2023. Why did it take so long to reach the moon's orbit? Well, simply because in order to save fuel and therefore weigh as little as possible, the trajectory taken by SLIM was long and complex, using a barely minimal amount of thrusters to gradually raise its altitude to finally reach the translunar injection orbit. The lander is equipped with a spherical probe that was developed by a Japanese toy company. Slightly bigger than a tennis ball, it can change its shape to move on the lunar surface almost like a transformer. November 2022, JAXA unsuccessfully sent a lunar probe named Omotenashi as part of the United States Artemis 1 mission. In April 2023, Japanese startup iSpace tried in vain to become the first private company to land on the moon, losing communication with its craft after what it described as a hard landing. Let us see if SLIM will be successful in bringing Japan to be the fifth nation to successfully land on the moon's surface, something not to miss. And of course, I will cover this monumental event and SLIM equipment and capabilities in the next episode. The Shenzhou 17 crew members, currently aboard China's orbiting space station Tiangong until April 2024, were seen accomplishing their first ever spacewalk, lasting 7.5 hours, marking a historic moment in the nation's space exploration endeavors and demonstrating Chinese extravehicular activity technology, or EVA. The crew went out to address minor damage to the Tiangong space station solar array. The difference with previous Shenzhou crew spacewalks is that this time they had to conduct a troubleshooting task, whilst previously it was more about assembling the Tiangong space station. NASA's Curiosity Mars rover has been on Mars for over 4,000 Martian days, or over 11 years. The rover captured its own shadow shifting across the surface of Mars using its black and white hazard avoidance cameras, or HAZCAMs. When Mars was in conjunction, meaning that it is at the opposite side of the solar system from Earth and therefore the Sun hides Mars from Earth, at that point, no communication can be established with Mars and any rovers. During that conjunction period, NASA programmed the Curiosity rover to take a set of pictures over a 12-hour period for the first time, which is what you are looking at on your screen. NASA was hoping to capture clouds and dust devil that could reveal more about the red planet's weather. The first video, featuring images from the front HAZCAM, looks southeast along Jedis Vallis, a valley found on Mount Sharp. Curiosity has been ascending the base of that 3-mile tall or 5-kilometer tall mountain, which sits in Gale Crater, since 2014. The second video shown the view of the rear HAZCAM as it looks northwest down the slope of Mount Sharp to the floor of Gale Crater. The rover's right rear wheel is visible, along with the shadow of Curiosity's power system. These videos are for the first time showing Mars from dawn to dusk. Starbase in Boca Chica has once again been relentless. Even in the last week of the year, we have seen further propellant tanks being delivered to the site, some final preparations to the orbital launch mount. They have concluded this week with Boost 10 and second Starship 28 static fires. We still do not know what are the fixes that needs to be done to either of these in order to prevent the same fate as for Booster 9 and Starship number 25. As far as we know, SpaceX Starship mishap report was not provided to the FAA, so we do not expect the Starship integrated flight number 3 just yet. December 22nd, Firefly launched his fourth Alpha rocket flight from his Space Launch Complex number 2 in Vandenberg Space Force Base in California for his mission called Fly the Lightning for the destination low Earth orbit at about 159-degree inclination. The payload is a wideband electronically steerable antenna demonstrator from Lockheed Martin as part of the responsive space capabilities that Firefly demonstrated back in September 2023, the 14th to be precise, with a Victus Nox mission. The trick here was to send a payload within 24 hours of receiving a purchase order. Despite some weather issues which delayed the mission, Firefly did this second flight response mission in the given time, which was another great achievement. Unfortunately, after the second stage engine cut off, it could not be relit, and therefore the satellite was not delivered to the right orbit, but instead at around 216 by 523 kilometer low Earth elliptical orbit and 140-degree inclination, which might therefore deorbit and burn in the atmosphere in the near future. The new wideband electronically steerable antenna sensor is expected to calibrate and be ready for operation in much less time than traditional on-orbit sensors, demonstrating the delivery of rapid capabilities to US warfighters stationed across the globe. However, it is unclear if the satellite will have enough time in orbit to complete the calibration. December 23rd, SpaceX launched 23 Starlink V2 mini satellites to circular low Earth orbit at 530 km altitude, 43-degree inclination for his mission Group 632 on board of a Falcon 9 Block 5 from his Space Launch Complex 40 at Cape Canaveral Space Force Station, Florida. The first stage, B-1058, landed 628 km downrange on the drone ship, just read the instructions, for his 19th times, which is another record in reusability. It was expected to be reused again, but tipped overboard due to wind and high waves when returning to port. This booster alone launched to orbit 2 astronauts and more than 860 satellites, totaling 260 or even more metric tons over a period of 3.5 years. Newer Falcon boosters versions have upgraded landing legs with the capability to self-level and therefore mitigate this type of issues. December 24th, SpaceX launched Sarah 2 and 3 satellites to circular low Earth orbit at 500 km and 88.2-degree inclination on board a Falcon 9 from his Space Launch Complex 4E at Vandenberg Space Force Base in California. The first stage landed for his 8th times back to site in Landing Zone 4. The satellites owned by the Bundeswehr, the German armed forces, built by Airbus, are phased array radar satellite for Earth observation. December 25th and 27th, Espace successfully sent 2 Kaizu 1A rockets with a total of 8 Tianmu-1 meteorological satellites from his Huaqiang Satellite Launch Center in China to a sun-synchronous orbit. For the recent viewers, sun-synchronous orbit means that the orbit angle is nearly passing by the Earth poles, which has the benefit to be lit by the sun with the same intensity throughout the whole day, which is perfect for Earth observation satellites, for example, and will eventually observe the whole Earth within 1 year. Espace, part of the state-owned China Aerospace Science and Industry Corporation, first established in 2016, and uses solid rocket motor focusing only on small payloads to low Earth or sun-synchronous orbits. This was the sixth flight of X-Space and Kaizu 1A in 2023, with the last launch over 4 months ago. December 25th and 26th, China Aerospace Science and Technology Corporation sent 2 Long March rockets, a Long March 11 from its sea launch platform off the coast of Yangjiang in China, with on board 3 Xi'an 24C satellites for space science and technology experiments, and a Long March 3B with 2 backup navigation satellites, Beidou 3 M25 and M26, to medium Earth orbit from its Xichang Satellite Launch Center in China. December 27th, the Russian Space Force launched a Soyuz 2.1V rocket from their Site 43-4 at the Plesetsk Cosmodrome in Russia, carrying the Cosmos 2574 payload to sun-synchronous orbit at an altitude around 350 km and 97-degree inclination. December 29th, SpaceX launched its 5th Falcon Heavy of the year out of Launch Complex 39A at Kennedy Space Center in Florida for its mission USSF-52 OTV-7, meaning the 7th flight of the orbital test vehicle, the launch of the United States Space Force X-37B spaceplane. The side boosters have flown for their 5th times with a return to site in landing zones 1 and 2. The center booster was expanded to provide more capability for the required payload. The X-37B was brought up to a Molniya-type orbit, so that's highly elliptical, high inclination orbit, based on marine zones, meaning that the trajectory closest to Earth will coincide with a maritime zone. However, the exact orbit remains classified. This allows the spacecraft to pass by a specific zone on Earth twice per day. The fairing halves would be recovered at 1,480 km or 920 miles downrange by the recovery vessel Dusk. December 29th, SpaceX launched 23 Starlink V2 mini satellites to circular low Earth orbit at 530 km altitude, 43-degree inclination for its mission group 636 on board of a Falcon 9 from its Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. The first stage, B-1069, landed 628 km downrange on the drone ship, a shortfall of Gravitas, for its 12th time. This marks the 98th and last SpaceX flight of 2023, including Starship flight tests, short of 2 flights, by the way, from Elon Musk's expectations set at the beginning of the year, which nevertheless is a massive cadence increase from the 61 launches in 2022 and the 31 launches in 2021. This week, I leave you with this image from ESA's Mars Express showing Korolev crater, which is 82 km wide, found in the largest lowland region of Mars called the Vastitas Borealis. Funnily enough, Vastitas Borealis means northern waste in Latin, as it is located in the northern region of the lowland. The image has a resolution of approximately 21 meters per pixels. It was created using data from the nadir and color channel of the high-resolution stereo camera. The color-coded topographic view shows the relative heights of the terrain in and around the Korolev crater filled with ice. Lower part of the surface are shown in blue and purple, whilst higher altitude regions show up in whites, browns and red, as indicated on the scale to the top right corner. The crater's thick deposit of ice can be seen at the center of the frame. This was your last episode of Espace News of the year. Thank you so much for joining me over the last month. The year comes to a close with 2023 rich in space technology, space news, and amazing images from the various telescopes in space. Have an amazing end of year celebration and see you again next year. Goodbye, everyone.